Direct burial is acceptable for grounding rods. However, they should be buried at least 2 feet below grade. Consider extending the rods or installing additional rods to ensure proper grounding. The connection between the 2 rods should be made with 4 American wire gauge bare copper wire. The connection from the grounding rods to the neutral bus bar should be made with 4 American wire gauge bare copper wire. Jump both the cold water pipe and the hot water pipe. Install a grounding jumper from the cold water pipe to the neutral bus bar. A grounding bushing is required for the service entrance conduit. Stucco repair is not strictly required for sign-off, but it is advisable to complete it promptly. Existing Romex can be extended using a wire nut and wire of the same American wire gauge and type. You do not need to reroute the extended wires to a junction box. Extensions can be made within 6 feet of the panel. The 1/0 lines should typically not need to be extended. There is typically no inline fuse at this point in the pull cavity. Breakers do not necessarily need to be identified for sign-off. The panel cannot protrude more than 1/4 inches into the exterior wall. You can build out the back of the panel in drywall to achieve a semi-flush install without exceeding the maximum protrusion. The distance from the service entrance to the neutral bus bar should not exceed 25 feet. The grounding resistance should be less than 25 ohms. Ensure that all connections are tight and secure. Be aware that the inspector may have additional requirements or concerns. Firstly, regarding the grounding system, it's essential to understand the requirements outlined in the National Electrical Code, (ONEC). While direct burial of grounding rods is generally acceptable, ensuring they are buried at a minimum depth of 2 feet below grade is crucial for effective grounding. If the existing rods protrude a few inches, consider extending them or adding additional rods to meet this depth requirement. Secondly, when connecting the 2 grounding rods, using 4 American wire gauge bare copper wire is the recommended practice. This wire size ensures adequate conductivity for carrying fault currents and providing a reliable grounding path. Replacing any existing smaller gauge wire, such as 6 American wire gauge, with 4 American wire gauge bare copper is essential for compliance with the NEC. Thirdly, the connection from the grounding rods to the neutral bus bar should also be made with 4 American wire gauge bare copper wire. This connection provides a low impedance path for fault currents to return to the source, facilitating the operation of overcurrent protection devices. Fourthly, when dealing with water piping systems, it is necessary to jump both the cold water pipe and the hot water pipe. This ensures that the entire metallic water piping system is bonded together, providing a continuous grounding path and minimizing the risk of electrical shock. Fifthly, installing a grounding jumper from the cold water pipe to the neutral bus bar is a critical step in establishing a reliable grounding system. This jumper provides a direct connection between the water pipe and the neutral, further enhancing the effectiveness of the grounding system. Sixthly, concerning the service entrance, a grounding bushing is typically required for the service entrance conduit. This bushing provides a means of bonding the metal conduit to the grounding system, ensuring that any fault currents in the conduit are safely conducted to ground. Seventhly, while stucco repair may not be a strict requirement for sign-off, it is advisable to complete it promptly. Addressing any cosmetic issues or repairs ensures a professional and aesthetically pleasing installation. Eighthly, when extending existing Romex wiring, it is permissible to use a wire nut and wire of the same American wire gauge and type. This method maintains the integrity of the wiring system and ensures proper current carrying capacity. Ninthly, it is not necessary to reroute the extended wires to a junction box. Extensions can be made directly within 6 feet of the panel, simplifying the wiring process and reducing the need for additional components. Tenthly, regarding the pull cavity, the 1/0 line should typically not need to be extended. However, if extensions are necessary, ensure that they are made using appropriate methods and materials to maintain the integrity of the connections. 11thly, there is typically no inline fuse at this point in the pull cavity. The absence of a fuse simplifies the wiring and reduces the potential for nuisance tripping. 12thly, breakers do not necessarily need to be identified for sign-off. However, it is recommended to label them clearly for future reference and troubleshooting purposes. 13thly, the panel cannot protrude more than 1/4 inches into the exterior wall. This limitation ensures that the panel does not obstruct pathways or create a safety hazard. 14thly, to achieve a semi-flush install without exceeding the maximum protrusion, you can build out the back of the panel in drywall. This method allows for a clean and aesthetically pleasing installation while complying with code requirements. 15thly, the distance from the service entrance to the neutral bus bar should not exceed 25 feet. This limitation minimizes voltage drop and ensures proper operation of the electrical system. 16thly, the grounding resistance should be less than 25 ohms. This requirement ensures that the grounding system is effective in dissipating fault currents and protecting against electrical shock. 17thly, it is crucial to ensure that all connections are tight and secure. Loose connections can cause overheating, arcing, and other hazards. 18thly, be aware that the inspector may have additional requirements or concerns. It is essential to communicate with the inspector and address any questions or concerns promptly to ensure a successful inspection. The installation of grounding rods serves several important functions. Firstly, it provides a low impedance path to ground for fault currents, which helps to quickly trip circuit breakers or fuses and prevent electrical shock hazards. Secondly, it helps to stabilize the voltage potential of the electrical system with respect to the earth, reducing the risk of voltage surges and transients. Thirdly, it provides a reference point for the electrical system, which is important for the proper operation of electronic equipment. When selecting grounding rods, it is important to choose rods that are made of a conductive material, such as copper or copper-clad steel. The rods should also be long enough to reach moist soil, which is necessary for effective grounding. In most areas, an 8-foot rod is sufficient, but in dry or sandy soils, longer rods may be required. The spacing between grounding rods is also important. The NEC recommends that grounding rods be spaced at least 6 feet apart to minimize the impedance between the rods and the earth. When connecting grounding rods, it is important to use a method that creates a low resistance connection. The most common method is to use a grounding clamp and bolt, which should be tightened securely to ensure a good connection. The grounding conductor, which connects the grounding rods to the electrical system, should be sized according to the NEC. The size of the grounding conductor depends on the size of the service entrance conductors. The grounding conductor should be run in a direct path to the service entrance equipment and should be protected from physical damage. When installing grounding rods, it is important to follow all applicable codes and regulations. The NEC provides detailed requirements for grounding electrical systems, and it is important to be familiar with these requirements before starting any work. In addition to grounding rods, other methods of grounding may be required in some situations. For example, a ground ring, which is a continuous loop of bare copper wire buried in the earth, may be required for large buildings or structures. A concrete encased electrode, which is a length of bare copper wire encased in concrete, may be required for new construction. When selecting a grounding method, it is important to consider the specific requirements of the installation and the local codes and regulations. Grounding is an essential part of any electrical system, and it is important to ensure that the grounding system is properly installed and maintained. A properly installed grounding system can help to prevent electrical shock hazards, protect electronic equipment, and ensure the safe and reliable operation of the electrical system. Regarding the service entrance, it's crucial to adhere to specific guidelines and requirements to ensure safety and compliance. Firstly, understanding the role of a grounding bushing is paramount. A grounding bushing is a specialized fitting designed to provide a secure connection between the metal conduit and the grounding system. It features a sharp edge or teeth that bite into the metal conduit, establishing a reliable electrical bond. This connection is essential for carrying fault currents back to the source, allowing overcurrent protection devices like circuit breakers to trip and to energize the circuit in the event of a fault. Secondly, the condition of the stucco surrounding the service panel is an important consideration. While minor cosmetic issues may not necessarily impede the final sign-off, addressing any significant damage or deterioration is advisable. Inspectors often prioritize safety and proper functionality over purely aesthetic concerns. However, neglecting obvious repairs could raise concerns about the overall quality of the installation. Thirdly, when it comes to wiring extensions, using appropriate techniques and materials is crucial for maintaining the integrity of the electrical system. For extending existing Romex wiring, employing wire nuts and conductors of the same American wire gauge and type is standard practice. Wire nuts provide a secure and insulated connection between the wires, while using conductors of the same gauge ensures consistent current carrying capacity throughout the extended circuit. Fourthly, the decision to reroute extended wires to a junction box is often based on practical considerations and code requirements. While it's generally permissible to make extensions directly within 6 feet of the panel without using a junction box, there are situations where rerouting becomes necessary. For example, if the extension requires running wires through walls or ceilings, a junction box may be needed to provide access for future maintenance or repairs. Additionally, local codes may dictate the use of junction boxes in certain scenarios, regardless of the distance from the panel. When dealing with the pull cavity, which is the space where service entrance conductors transition from underground to the meter and main panel, several important factors come into play. Firstly, the length and condition of the service entrance conductors are critical. Ideally, the existing 1/0 line should have sufficient length to reach the meter lugs without requiring extensions. However, if extensions are unavoidable, it's essential to use appropriate splicing methods and connectors to maintain the integrity of the conductors. Secondly, the presence of an inline fuse in the pull cavity is not typical. Service entrance conductors are usually protected by the main circuit breaker in the panel, rather than an additional fuse at the point of connection. If any unusual configurations or components are encountered, consulting with a qualified electrician or inspector is advisable to ensure compliance with local codes and regulations. As for breakers, identification is crucial for safety and convenience. While some inspectors may not explicitly require breaker identification for sign-off, it is highly recommended to label each breaker clearly with its corresponding circuit or load. This practice simplifies troubleshooting and maintenance, making it easier to identify and to energize specific circuits as needed. Regarding panel flushes, exceeding the maximum protrusion limit can create safety hazards and violate building codes. Building out the back of the panel in drywall can be a viable solution for achieving a semi-flush installation without compromising safety or compliance. This approach involves extending the wall cavity behind the panel to accommodate its depth, resulting in a cleaner and more aesthetically pleasing appearance. The importance of the distance from the service entrance to the neutral busbar cannot be overstated. Keeping this distance within the specified limit is crucial for minimizing voltage drop and ensuring optimal performance of the electrical system. Excessive voltage drop can lead to dimming lights, malfunctioning appliances, and other issues, so it's essential to adhere to code requirements. The grounding resistance is a key indicator of the effectiveness of the grounding system. Maintaining a grounding resistance below the specified limit is essential for providing a low impedance path for fault currents, which helps to quickly trip circuit breakers and prevent electrical shock hazard. When performing electrical work, it's essential to prioritize safety and take precautions to prevent accidents. Firstly, always to energize circuits before working on them. Use a voltage tester to verify that the power is off before touching any wires or components. Secondly, wear appropriate personal protective equipment, such as safety glasses and insulated gloves. This equipment can help to protect you from electrical shock and other hazards. Thirdly, follow all applicable codes and regulations. The NEC provides detailed requirements for electrical installations, and it's important to be familiar with these requirements before starting any work. If you're unsure about any aspect of the work, consult with a qualified electrician or inspector. Lastly, never work alone. Having someone nearby can provide assistance in case of an emergency. In addition to the above, here are some additional tips for ensuring a successful electrical installation. Firstly, plan your work carefully. Before starting any work, take the time to plan out the entire installation. This will help you to avoid mistakes and ensure that the work is done safely and efficiently. Secondly, use quality materials. When selecting materials for your electrical installation, choose quality products that are designed for the specific application. This will help to ensure that the installation is reliable and long-lasting. Thirdly, take your time. Don't rush through the work. Electrical installations should be done carefully and methodically to ensure that they are done correctly. Fourthly, inspect your work. After completing the installation, inspect your work carefully to ensure that everything is done correctly. Check all connections to make sure they are tight and secure, and verify that all components are properly installed. With careful planning, quality materials, and attention to detail, you can ensure a safe and successful electrical installation. Always consult with a qualified electrician if you have any questions or concerns. Remember that working with electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others. Firstly, for proper grounding, ensure that you drive the grounding rods deep enough into the earth to reach consistent moisture levels. In drier climates, this may require longer rods or additional grounding electrodes. Secondly, when connecting grounding conductors to grounding rods or other grounding electrodes, use approved connectors and techniques to ensure a reliable and corrosion-resistant connection. Thirdly, when bonding metal water pipes, gas pipes, or other metallic systems to the grounding system, ensure that all connections are made on the customer side of any insulated fittings or unions. Fourthly, when extending existing circuits, use wire connectors that are appropriately sized for the conductors being joined and are listed for the intended application. Fifthly, when installing electrical panels, ensure that they are securely mounted to the wall or the supporting structure and that all knockouts and openings are properly closed or sealed to prevent the entry of moisture or pests. Sixthly, when routing cables and conductors through walls or other building components, use appropriate methods to protect them from physical damage, such as using conduit or cable staples. Seventhly, when making connections to circuit breakers or other electrical equipment, ensure that the conductors are properly sized for the equipment and that all connections are torqued to the manufacturer's specifications. Eighthly, when labeling circuit breakers or other electrical equipment, use clear and durable labels that accurately identify the circuits or equipment being served. Ninthly, when inspecting electrical installations, pay close attention to any signs of overheating, corrosion, or physical damage and take corrective action as necessary. Tenthly, when working with electrical equipment, always follow the manufacturer's instructions and recommendations for installation, operation, and maintenance. Regarding wire selection, firstly, use the correct wire size for the ampacity of the circuit. Refer to NEC Table 310.16 for ampacity ratings of insulated conductors. Secondly, use the correct type of wire for the environment. For example, use THHN wire for dry locations and THWN wire for wet locations. Thirdly, use copper wire for most applications. Aluminum wire is less conductive than copper and requires larger sizes. Fourthly, use stranded wire for flexibility. Stranded wire is easier to bend and pull than solid wire. Fifthly, use color-coded wire for easy identification. Black wire is typically used for hot conductors, white wire is typically used for neutral conductors, and green wire is typically used for grounding conductors. As for conduit fill, firstly, do not exceed the maximum conduit fill percentage. Refer to NEC Chapter 9 for conduit fill tables. Secondly, use the correct size conduit for the number and size of wires. Thirdly, use conduit fittings that are compatible with the conduit and the wires. Fourthly, use pull boxes or junction boxes for long conduit runs or multiple bends. Fifthly, lubricate the wires before pulling them through the conduit. For overcurrent protection, firstly, use the correct size circuit breaker or fuse for the ampacity of the circuit. Secondly, do not oversize the circuit breaker or fuse. Thirdly, use circuit breakers or fuses that are listed for the intended application. Fourthly, install ground fault circuit interrupter, or GFCI, protection for circuits that serve bathrooms, kitchens, and outdoor areas. Fifthly, install arc fault circuit interrupter, or RFSI, protection for circuits that serve bedrooms. And for grounding and bonding, firstly ground all metal enclosures. Secondly, bond all non-current carrying metal parts. Thirdly, use a grounding electrode system that meets the requirements of the NEC. Fourthly, use a grounding conductor that is sized according to the NEC. Fifthly, use a bonding jumper that is sized according to the NEC. For working safely, firstly, always energize the circuit before working on it. Secondly, use insulated tools. Thirdly, wear safety glasses. Fourthly, wear rubber gloves. Fifthly, use a ladder that is in good condition. Sixthly, do not work in wet conditions. Seventhly, do not work alone. Eighthly, follow all applicable codes and regulations. For final thoughts, firstly, double-check all connections. Secondly, test all circuits. Thirdly, label all circuit breakers. Fourthly, clean up the work area. Fifthly, call a qualified electrician if you have any questions or concerns.